Hello guys, algebraic expression. The objective is to find the domain of definition of a rational expression, or by asking the question in another way, to find the values of x for which the rational expression is defined. Fractional expression in the form p of x over q of x. By definition, consider the expression f of x equal p of x over q of x. P of x and q of x are two polynomials in x. F of x is called a fractional expression. The literal fractional expression is defined if his denominator does not equal to 0. So q of x does not equal to 0. This is a fractional expression. Okay, f of x is defined when its denominator does not equal to 0. Okay, for example, f of x equal to x minus 1 over x plus 1. The question is, find the domain of definition of f of x, or find the values of x for which f of x is defined. Two questions related to the same solution. Okay, look at the denominator x plus 1. So x plus 1 does not equal to 0. This means x does not equal to minus 1. So f of x is defined when x does not equal to minus 1. This means all numbers are defined except minus 1. So all numbers except minus 1. The domain of definition is all real numbers except minus 1, because if you replace x by minus 1, become minus 1 plus 1, it becomes 0. Then f of x is undefined because we have 0 in the denominator. So we know x does not equal to minus 1 to avoid 0 in the denominator. Application: consider the following fractional expression: 6 over x. X does not equal to 0. The domain is all numbers except 0. Another one, look at the denominator 3x plus 1. 3x plus 1 does not equal to 0. 3x does not equal to minus 1. Then x does not equal to minus 1 over 3. Okay, the domain is all real numbers except minus 1 over 3. Another one, this is the denominator of the fractional expression. X squared minus 10x plus 25 doesn't equal to 0. We know the remarkable identities. So x squared minus 10x plus 25, it's equal to x minus 5 squared. Does not equal to 0. This means x minus 5 does not equal to 0. Then x does not equal to 5. So all numbers except 5. This is the domain of definition. All real numbers except 5. Because if we substitute 5, it becomes 3 over 0, and this form is undefined. X minus 3, x plus 8 does not equal to 0. Okay, x minus 3 does not equal to 0. This means x does not equal to 3. X plus 8 does not equal to 0. This means x does not equal to minus 8. Then the domain is all numbers, all real numbers except 3 and minus 8. 1 over x squared plus 1. X squared plus 1. Okay, look at this polynomial in the denominator, x squared plus 1. X squared is always positive or equal to 0 when x equal to 0. So this is greater than or equal to 0. And 1 is positive. Then the polynomial x squared plus 1 is always positive and cannot be equal to 0. Okay, so you can replace x by any number, and in the denominator we don't have any 0. Okay, so x squared plus 1 is positive. Then the domain of definition is what? All real number. All real numbers, because x squared plus 1 is always positive. If you replace x equal to 1, minus 1, 6, minus 1 over 2, any number, it's always positive. Exercise: determine the values of x for which each of the following expression is defined. We have a 3 fractional expression. The first one, look at the denominator. We have x into 3x minus 12. It does not equal to 0 to become defined. X into 3x minus 12 does not equal to 0. This means x does not equal to 0, and 3x minus 12 does not equal to 0. Okay, then 3x does not equal to 12. X does not equal to 12 over 3. X does not equal to 4. The domain of definition is all real numbers except 0 and 4. Another one, you can pause the video and try to solve this. Okay, I will complete the second one. Look at the denominator, x squared minus 4, take it does not equal to 0, then x squared minus 4 does not equal to 0, x squared minus 4 is different between 2 squared, then it's equal to x plus 2, x minus 2 by factorize it. This means the first parenthesis does not equal to 0 and the second one does not equal to 0. X plus 2 does not equal to 0, this means x does not equal to minus 2, and x minus 2 does not equal to 0, x does not equal to 2. So the domain of definition is all real numbers except minus 2 and 2. The third one, this is the denominator, does not equal to 0, x minus 7 into 2x plus 5 does not equal to 0, x minus 7 does not equal to 0, x does not equal to 7, and 2x plus 5 does not equal to 0. Moving plus 5 to the right hand side to become minus 5, 2x does not equal to minus 5, x does not equal to minus 5 over 2 by dividing by 2. Okay, so these are the values of x. That f of x cannot be equal to 7 or minus 5 over 2 to avoid 0 in the denominator. So x does not equal to 7, x does not equal to minus 5 over 2. The domain of definition is all numbers except 7 and minus 5 over 2. Then f of x is defined when x does not equal to 7 and x does not equal to minus 5 over 2. Okay, try to solve this. Find the domain of definition of this fractional expression and share the answers with your teacher. Thank you.